Unit 1, it's about errors. Have you ever heard about error? What is error?
Error.
Yes.
Error in maths.
Yes. Okay, it's fine. Let's continue.
Oh no, error.
Yeah.
This one, Nebon.
Yeah. Okay. So today we're going to learn about errors and its type. Okay. So let's start. Before learning about types of errors, let's learn about what is error. Error is a measurement that is based of all experimental science and technology. Okay. So in mathematics, error is a different between the true value and measured value. Okay, so here in maths it's gonna be a different between measured value and a true value.
Okay.
Yes, so we can write it like this: error equals to measured value minus true value. Ne? And then when we write in equation form, it's gonna be an absolute bar of change in x equals to xa minus xt. So this change in x, we call it absolute error. Okay, absolute error. And then this xa, we call it a measured value or assumed or estimated. This xa is the value that we estimate or guess or measure. Okay, it's a measured value or guess or assumed or estimated. Okay, and then xt is a true value or exact value. Okay, let me write it on the other side. So feel free to ask any question. Feel free to tell me if I'm too fast so that I can slow down. Okay.
Okay, no problem. So far, we're cool.
Okay, let me write this down. The absolute change in x, I said this is called absolute error. And then xa, it's measured or assumed or estimated. And then xt, I said xt, it's a true or exact value. Okay, so moving forward, we're gonna make an example. So let's say we are buying a phone, and when we buy a phone, on the specific of the phone, they say the length of that phone is 15 centimeter. Okay, we bought a phone, the phone length is 15 centimeter, and then when we measure that phone, we get 15.2 centimeter. Okay, and then from this information, they say we have to calculate error, the absolute error. So the 15 centimeter that comes with the phone, we call it true value. This is the true value that they come with the phone. And then 15.2 centimeter is the one that we measure, like we measured. Okay, so to calculate error, so it's gonna be absolute bar change in x equals to what? Xa minus XA minus XT. So XA is a measured value, which means it's going to be what? A 15.2 minus 15. So this is how we calculate the absolute error. 15.2 minus 15 is 0.2, so it's going to be 0.2 centimeter. Okay, so we have the true value. This one, it comes with the phone, and then this one, we measured it. We can measure it with ruler or tape, and then we find out, okay, it's what is 15.2 centimeter. So this is how we calculate errors. Okay, so here, while we're still under error, oh, do you have a question?
No, this one is straightforward.
It's
I see.
Okay, straightforward. So remember, this one, we call it what? Absolute error. Absolute error. So while we're still under errors, we have this relative error. We also have what? Relative error. Relative what? Relative error. So relative error, it's R, small letter R. The formula for this relative error, it's R equals to absolute change in X over XA. Okay, absolute bar. Okay, so this is the formula for what? For relative error. Remember, we have already calculated the change in X. We also have XA, right? We found change in X as what? As 0.2. And then our XA was 15.2. So to calculate this, we're just going to substitute what we've calculated when we're calculating what? The absolute bar. So the relative error here is going to be what? 0.2 over 15.2. Okay, and then we get the answer. Do you have your calculator? Closer. Clement, I'm tutoring and you are disturbing me. Sorry. I'll phone you later. Hello, can you hear me? Bongan? Hello? Are you... Oh my goodness. Are you still here? Hello? Bongani.
I can.
Oh, you can
I
hear
think maybe it's your network.
Oh,
Because
yeah.
I can hear you.
Okay.
Yes.
So did you calculate?
Yes,
How much did you get?
I did calculate.
How much did you get?
I got 0.01.
0.013. Okay, yes. So this is how we calculate relative error. While we're still under errors, we still have this thing called percentage error. Percentage error.
Okay.
So percentage error, it's PR. So the formula for PR, it's PR equals to 100 multiplied by R. We've already calculated the R, right? So it's we're just going to multiply it by what? By 100. 0.013. And then you get your percentage, right? So it's going to be 1.31. Okay,
31,
yeah,
yes.
percent. So under errors, we have absolute error with that equation changing X is equals to XA minus XT. We also have what do you call the relative error, which is
The
R.
relative error.
Yes, which is R absolute bar changing X over XA. So and then we also have percentage error. Okay.
Yes.
Yeah. So let's do a activity. I don't know if you have the textbook. Do you have textbook?
I'm not sure if it's the correct one that I have.
Yeah. The PDF one.
Yeah, I think so. I think it's the same, but I'm not sure.
You're not sure. Let me see. But you see, unit 1, it's about uncertainty error, right?
Wait, let me
Page
open.
2.
Yeah, I think. Yeah, I see. Unit 1 measurements
Yes.
and yeah.
Uncertainty errors. Yes, it's all about
Yes.
errors. Yes. So here I was just showing how to apply, how to use the formulas. Okay. We have
Yeah.
absolute error, we have percentage error, we also have relative error. So there is class activity there, activity 1.1. Ne? You see it?
Yeah.
Okay, let's
Yes.
do it. Let's do activity 1.1. So 1.1, it says an iron rod of length 100 millimeter is heated and allowed to expand by no more than 0.5 millimeter on either side. So we have an iron rod. Let's say this is our iron rod, and then from here to here they say it's 100 millimeter. The length of iron rod is 100 millimeter. Okay, and then they say it's heated and allowed to expand by no more than 0.5. So on either side, so it expanded on both sides with 0.5 mm. Okay, and then the first question, they say determine the value XA that may be assumed to be closest to the true length. Can you please try to answer A?
Okay.
Yeah. So what is the value of XA that may be assumed? Remember I said XA is a measured value.
Measured
Yeah.
against one.
Yes. Or
Oh,
estimated.
against one. Yeah. Wouldn't it be the 0.5 to
You say 0.5?
hello?
Yeah, I'm still here.
And then okay. And then our true value I think it's 100 because this is given. Our rod is 100 millimeters.
Yes, our XT very yes, it's 100. And then they want us, number A, they want us to determine XA. We want XA here.
Oh.
Yes. So
I see.
yeah, XA, it's measured, like we measure from wherever is expanded to wherever is expanded, from 0.5 to 0.5. We're gonna add everything, like we are measuring, we're gonna guess it, like 0.5 plus 100 plus 0.5. That's gonna be what? Our XA. Remember, XA is measured, assumed, guessed. So our XA is gonna be 0.5 plus 100 plus 0.5, which is 101 mm. So question 1, number A, we only want this answer, 101. This one, yes, you're right. Our XT, it's 100. So since we know XA and XT, which means you can determine the absolute error, right? And the relative error and the percentage error, right? So I want you to do number B. Or you can just tell me, okay, absolute error is gonna be so, relative error is gonna be so, and then percentage error is gonna be like this.
Let me do it first.
Okay. Yeah, you can take time. Maybe, okay, I'm giving you 3 minutes.
All right. So
Our absolute error.
our absolute error, we're going to minus 100 from the 101 that we got. And we calculated XA, which is
Yes.
our 0.5 plus 100 plus 0.5, which gave us 101 millimeter.
Yes. So
And then our absolute error is going to be our XA minus XT,
yes.
which is 101 minus 100.
Yes. Yes. And then which is gonna be 1.
Yes.
Yes. And then a relative error.
Relative error is going to be our absolute error divided by measured or
Yes. Yes. Measured
Yes.
value, which is gonna be 1 over 101, and then we get the answer, which is 0.099.
yes,
And then the percentage error, we're just gonna multiply it by 100.
by 100. Yes.
Yeah, great. And then yes, that's what we do under errors. So it's absolute error, relative error, and then percentage error. Okay, and then now let's go to number 2. Am I too fast?
No,
Okay.
I understand you. I understand you very well.
Okay, no problem. So moving forward, number 2 under activity activity 1.1. Number 2, they say determine, and they say for a displacement transducer having calibration y, we're given y equals to Ke, right?
Yes.
Where K and E are sensibility indices, estimate the uncertainty in displacement y. If E, we're given value of E, which is 5, and then we're also given value of K, which is 10.10. We're also given change in K equals to plus or minus 0.10, and then we also have change in E, which is 0.01. So remember here they said they want us to estimate the uncertainty in displacement, ne?
Yes.
In mathematics or physics, the first derivative we call it displacement, ne? And then second derivative we call it velocity. You know this. And then third derivative we call it acceleration. So here they want us to estimate the uncertainty in displacement. So displacement is first derivative, which means here on number 2 we're gonna derivate our equation once, because it's gonna be what? It's gonna be displacement. Okay, and then that's where we're gonna get the answer. Okay, so what we're gonna do, we're gonna derivate this. Do you know how to derivate, right?
Yes. If I may ask,
Yes.
you see, when we started from the first one that we did, or the first example that you did before we go to the activity,
Yes.
you were calculating in centimeters, and now on this activity we calculated in millimeters, so it doesn't matter which values you gave us.
No, it doesn't matter as long as all the units, the SI units, are the same. Let's say they are all millimeters, it's fine. They are all centimeters, it's fine. But if you are given millimeter and centimeter, you have to change to 1.
All right.
Yes. So here on the second equation, we're gonna derivate once so that we get what? Displacement. So you say you know how to derivate, but if you don't still remember, I will remind you. Don't worry, I'm here for you. Okay. So this is our equation. This equation is a product because K multiplied by E, it's a product. We're multiplying. Okay. So do you have any idea how are we going to derivate this? Y is equals to Ka. We're going to derivate Y in terms of K and E. Do you have any idea how can we do that?
Not really, I don't remember.
Okay, it's fine. So to derivate this, we want the derivative of y with respect to k and e. And then this is what? This is the product, k and e. So which means we're going to use a product rule to derivate. So it's going to be changing y. Remember, we're derivating this y. Y is equals to k. Okay, so it's going to be changing y equals to. So since we are derivating y with respect to k and e, here is gonna be what? A change in y over change in k. Okay. Actually, let me do this. It's the same thing. No, let's start this way. So it's a product rule. So product rule, we copy and then we derivate, we copy and then we derivate, né? When it comes to product rule. So we're gonna start with k, we're gonna copy k and then we derivate e. Okay, we start by copying k plus we're gonna copy e and then we derivate what? K. Like this. So product rule, we copy and then we derivate, copy and then derivate. So we start by copying k and then we derivated e, and then secondly we're gonna add and then we copy e and then we derivate k. Do you get it?
Yes, I do.
Okay, so okay, this is our equation and then we derivated. So changing y is equals to, when we derivate ke is a product rule, we're gonna copy and then we derivate and then we add, we copy and then derivate. So we have the value of k, which is 10.10, and then we have the value, we have the value of changing e. It's gonna be 0.01 plus e is 0.10 times, it doesn't matter the plus or minus, okay, because we put the absolute bars here. We're gonna put the absolute bars. Okay, 0.10 multiplied by changing k, e multiplied by e, which is 5, and then you're gonna get your answer. When I calculated, I got 0.601. So when they say displacement, remember displacement is the first derivative. If they say velocity, we were gonna derivate twice, okay, and then if they say acceleration, we were gonna derivate 3 times. Are you following?
Please repeat that.
Okay, here in this question, they say they want us to estimate displacement. So displacement, we only derivate once, okay? And then velocity, we derivate 2 times, okay?
Yes.
And then acceleration, we derivate 3 times, ne?
Yes.
Yeah. So moving forward, remember you haven't started, and I heard that test is next week, right? Saturday. So we're gonna move a little bit faster. So let's do 1.2, evaluating error using the method of small change. Yeah?
Yes.
1.2. So we're going to evaluate maximum error using the method of small change.
First test is
50.
Yo.
Yeah, I think each test contribute like 25%. I'm not sure. But I think it's 25. No, I'm lying. I'm not sure, but I think it's out of 50 and then it contributes some percentage. I'll check the study guide and then I'll tell you. Evaluating maximum error using the method of small change. Okay, so we're going to do 1.2. So for sure you know this, that y is the same as f of x, right?
Yeah.
And then if we're derivating, it's going to be y prime is equals to f prime. This is the first derivative, right? And also we can write the derivative like this: dy over dx is the same as f prime of x. This is the other form of differential. Okay, this is the other form how to derivate. So here we can make dy subject to the formula. So we're gonna have f prime of x multiplied by dx. Here we just make dy subject to the formula. Okay, so when we want to estimate the resulting error, we use approximation. So we're gonna write it as change in y over change in x equals to dy over dx. So this is when we want to estimate the resulting error. We use the approximation. Okay, this is the approximation. And then from here we have the change in y over change in x is equals to dy over dx. So from here we can make change in y subject to the formula. So we're going to have change in y equals to dy over dx change in x. Okay, we made change in y subject to the formula. So from here we can just introduce the absolute bar, and then the equation is gonna be called, this equation we're gonna use it to estimate maximum error. So we're gonna use this equation to estimate maximum error. Okay, dy over dx multiplied by change in x. So this one is gonna be estimate maximum error. Estimate maximum error. So when they give you question, or they will say, okay, determine the they will ask you to estimate the maximum error in the equation. So to do that, we're gonna use this formula: change in y is equals to dy over dx change in x. So if they ask you to estimate the maximum error in the function, and then they're gonna give you the value of x and the absolute error. So let's do an example and show you how to use this equation. Do you have any question so far?
No, not yet.
Okay. For example, we're gonna use example 1.3 from the textbook. So here they say estimate the maximum error in y if y, we're given y is equals to sine square x, and then they say for x is equals to 0.1661 plus or minus 0.005. Okay, so we are given this: x is equals to 0.61 plus or minus 0.005. Okay, so from this function, 0.61, okay, is the value of x, and then plus or minus 0.005 is the absolute error. It's absolute error, which is change in x. Okay, so we're given the value of x, we're also given the value of what? Change in x. And then they want us to estimate the maximum error of y is equals to sine square x. Okay, so we have the formula to estimate. Our formula is absolute change in y equals to dy over dx multiplied by change in x. Okay, so we are given the value of change in x, which is 0.005, and then we're also given the value of x, which is 0.61. This is dx. So what we're going to do here, we're just gonna remember our function is sine square x, like this, and then we want to to substitute in this equation. We're looking for the maximum error in y. Okay, so dy over dx is the derivative of what? Of this function.
Oh, I see.
Yes, of this function. So what is the derivative of sine square x? Derivative of sine square x?
Oh,
It's there on the textbook. It's 2 sine x cos x.
yeah, I was getting there.
Yeah.
So
Okay, no problem. So it's gonna be 2 sine x times cos x. Okay, multiply by change in x. Our change in x, you know, it was what? 0.005. Okay,
yes.
and then we also have the value of x, which was 0.61. So wherever there's x, we're gonna put 0.61. So it's gonna be 2 sine 0.61 multiplied by cos 0.61. Okay, time is absolute of 0.005. Yeah, here it's 0.005. Okay, at the end, and then you're gonna get the answer. So the answer on the textbook, it's how much? Or you can calculate. I want to see something. Can you please calculate this? Absolute of 2 sine 0.61 multiplied by cos 0.61.
It's 2 sine 0.61 times
Cos
0.61.
Yes. With the absolute bar, we have the absolute bars. Multiply by absolute 0.005.
0.005.
Yes. Multiply by absolute 0.005. How much are you getting?
0.0. My calculator is in.
Okay, yeah, I wanted that. So whenever your function has trigonometric, if your function it has trigonometric, you have to change your mode of calculator to radian.
Oh, you see, I am following.
Yes, you are.
At least I do remember.
Yeah. Yes. So you're gonna get 0.004847.
Yes.
Yeah. So when we write our answer, we write it with the inequality. So it's gonna be less or equals to all the time. All the time we write our answer in inequality form. Okay. So it's gonna be less or minus 0.0. It's 0.048. Yeah, 0.00446 or 47. Okay, something like that. Okay, and then after getting your answer, okay, we're gonna move forward. We're gonna take this y is equal to sine square x. Okay, we're gonna take this y is equal to sine square x. So after writing it down, you're gonna substitute the value of x, which was 0.61. So we're gonna have sine squared 0.61. Okay, and then you get the answer.
Sine squared
into 0.61.
0.61.
You got how much? 0.32. 281.
No.
Uh-huh.
You know what my calculator is doing?
Mm-hmm.
I think I need to change my calculate back to scientific mode.
No, you know how to calculate this. Remember, it's in radian. So you're gonna press sign and then 0.61, and then you close the brackets, and then you say squared. That's how you're gonna calculate it.
Yes, I calculated it in that way.
Yes.
But the answer that I'm getting is, I'll read it out for you.
Okay.
Now. It's 1.133 times 10 to the power minus 4. So you see.
Okay, you know what to do? Press Shift and ENG. Shift ENG.
Shift ENG.
So that you can get decimal place.
Yeah, I see.
You're getting that.
Yeah.
No, you didn't change your calculator to radian, right?
Yes.
You have to change it to radian all the time. Remember, whenever you have a trigonometric, you change your mode of calculator to radian all the time. All the time, okay?
Okay.
Yes, so you're gonna get 0.32818. Right? You get the same. Did you get the same?
Yeah, I'm getting 0.321818 something.
Yes. So all the time when you have a trigonometric, when you have the sine, cos, tan, cosh, those trigonometric, you change your calculator to radian all the time, ne?
Okay.
Yes, so the reason why we are calculating this, we want the interval. So to get the interval, this is how we calculate the interval. So the y is going to be between this and this. On your right hand side, it's going to be 0.32818 minus the answer that we got this side, minus 0.0046. Okay, so to get the intervals, we start by calculating with the original equation, and then we get the answer. After getting the answer, we get the intervals. To get the interval, we're going to say 0.32818 minus 0.0046. And then on our right hand side, it's going to be 0.32818 plus 0.0046. And then this is what we call intervals. The question will come and say calculate the intervals. This is what you do, okay? The intervals. This is how we do the intervals, okay? We call this intervals. Do you have any question?
No, not yet.
Not yet. So which means you're following, right? So we did example. Now let's do activity. Okay, so we have activity with this estimating the maximum error. You see activity 1.2.
Yes, I see.
Yeah, 1.2, they say determine the maximum error for y is equals to 1 plus cos x, x is equals to 0.5, and then changing x is equals to 0.01. So I'm going to do number A, and then you're going to do number C, okay?
Okay.
Let me start by A. A, it's what? It's y is equals to 1 plus cos x. And then they say x is equals to what? 0.5. And then changing x is equals to 0.01. Okay, and then we have our formula. So this is what we're gonna do. The derivative of 1 plus cos is gonna be, derivative of 1 is 0, and then derivative of cos x is gonna be minus sine x, okay? Multiply by changing x, and then we substitute. So 0 minus sine x is the same as minus sine x. So here it's gonna be minus sine, our value of x is what? It's 0.5. Yeah? And then our change in x is what? Is 0.01. And then we get our answer. Remember, our answer, we write it in equality.
Equality, yes.
Yeah, so it's going to be less or minus, and then we get the answer. So, let me calculate. So the answer is going to be 0.0048. Okay? Remember, the calculator is supposed to be what? In radian. In radian. Yes. And then after here, we're going to take the original equation and substitute the value of x. So it's going to be y is equals to 1 plus cos 0.5, and then we get the answer. So from here, we're going to say y equals to 1 plus cos 0.5, and then we get the answer, which is 1.8775. Okay, we can round off our decimal place to 4. We can run this answer to 4 decimal place. Okay, and then after getting the answer, we're gonna get the intervals. Okay, remember the intervals. So it's gonna be 1.8775 minus this answer, 0.0048. Yeah? And then 0.0048, and then this one is going to be 1.775 plus 0.0048, and then we're going to calculate this and then get 1.8727 this, and then this side we're gonna get 1.8. Before
you move
yeah,
can we please go back to, you see when we derivated 1 plus cos x?
Yes,
please go back.
Okay, let me go back here.
Yeah, here I'm not getting this 0.0048.
How much are you getting? Don't forget to change your calculator to radian.
Okay, let me change. Number 4. Yeah, I'm on radian now.
Okay,
so it's 1 minus sine 0.5.
It's minus. This is the absolute bars. This is the absolute bars. Okay.
Oh.
Sorry. So when we derivate this, derivative of 1 is 0. Derivative of cos x, it's minus sine x. And then 0 minus sine x, it's negative sine x. So here we just put the absolute bars from the equation, from this equation. These are the absolute bars.
Okay.
So you're getting the answer.
Wait, let me.
Yeah, try to calculate.
Yeah, I'm getting 0.00479.
Okay.
Yeah, which is 0.0048.
Yeah. Okay. Happiness, right?
Yes.
Yes. And then we got this answer. And then after getting the answer, we're going to take our original equation. Okay. Y is equals to 1 plus cos x. And then we substitute the value of x. This is what we did this side. So it's y plus cos 0.5. Which we got what? 1.8775. Don't forget your calculator. It's supposed to be in radian.
Okay. Okay, yes.
Yes. And then we got the answer. After getting the answer, we're going to get the intervals. This is what we called what? Intervals. These are the intervals. So on the left hand side, we subtract, and then on the right hand side, we add, right?
Okay.
Yeah.
So we add and then we subtract.
Yeah, on the left, we subtract. On the right, we add.
Okay.
Yeah, this is our left. This is our right. So I want you to do number C. Or maybe you can pick any.
Okay.
Which one do you want to do from B to F?
I'll check which one is challenging.
You want to do the challenging one?
I need to.
Okay. So which one are you picking here? I'm gonna give you 3 minutes.
Okay.
Which one?
Let me check. I can move. I can do number D.
Okay. Go for it. I'm giving you 4 minutes. I want okay, after this one I want us to do 1.3. So Rochi, and you know Rochi, ne?
Yes.
Yes, the one that she recommended to me. So
Yeah.
yesterday Rochi and I, we did up to 1.3, evaluating maximum error for function of two variables. So maybe on Wednesday we can do class together with Roshi and then continue. So today me and you, we have to do 1.3 also. So I'm giving you 4 minutes to do number D.
Okay.
Yeah.
This thing is going to be low. The derivation of sec x.
You don't know the derivative of sec x?
Yeah, isn't it sec x times times tan x?
Yes, it is. Yes, you're right.
I'm right.
Yes.
Oh, I should. I remember some.
Yeah, you still remember. So sec, remember, is the same as 1 over cos x, ne? When you calculate, yes. Because on the calculator we don't have sec. So sec is the same as 1 over cos. Don't forget the mode of calculator. Radian.
Let's hope I'm getting the correct things here.
Okay.
Because
change in y. Have you calculated change in y?
Change in y.
Yeah.
I hear a change in y is equals to
dy over dx.
dy over dx times
change in x.
Change in x, yes.
Mm.
And then I'm going to derivate
sec
my y.
Yes.
Which is going to give me sec x times tan x,
yes.
which is 1 over x times tan x.
Yes.
So now it's going to be we're going to substitute that since we have x the x already.
Yeah, we have the x value, which is 0.12, and then
0.12.
Yeah, and then which is we also have change in x, which is 0.01.
So now there is going to be 1 over cos 0.12.
Yes.
Multiplied by tan 0.12.
Yes.
Yeah, I'm opening those bars on the side.
Yes.
Divide, multiply by 0.01. What did you get? I'm getting.
Yeah. What are you getting?
0. I don't. Okay, 0.0012.
Yes. Great. We got the same answer.
Correct.
Yes.
Okay.
Yeah.
I'm just doubting myself. You see, I still remember this thing.
Yeah, you see. So don't forget the last answer. You have to write in inequalities, less or equals to 0.0012.
Yes, I did that.
Yeah, and then after that you're gonna take the original function and then put the value of x and then get the answer. After that you do the intervals. Okay,
so now our y is going to be, since we don't have since we don't have sec, it's going to be y is equals to 1 over cos x.
Yes. Yes.
Okay, 1 over cos 0.0012.
No, our value of x is what?
Okay, our value of x is 0.12.
Yes. You got.
I'm getting
1.0072.
Yes.
Okay, great. And then we're gonna subtract 0.0012 on the left, and then we're gonna add on the right? And then that's your intervals. Then we're done with number D. Okay.
So fast.
Yeah, it's easy, right?
Yeah, I think it's way too easy.
Yeah, it's easy.
Okay, let me do the intervals.
Okay.
So when I minus, I get 1.006.
Yes.
And then when I add, I get 1.0084.
Yes, we're getting the same. We are getting the same. Okay, moving forward.
So the only trick, if I may add or ask,
yes,
the way I understand this, the only trick with this thing is to understand the derivatives.
Yes,
because if I say derivate my sin x or cos x, the one that they gave me, it means I'm going to get wrong answers.
Yes, you just have to know how to derivate.
Okay.
Yeah, and I think I should just remind you the rules of derivative rules. Do you still remember the derivative rules?
Remind me.
Okay, let's write them down.
Okay.
Derivative. So number one, we have the power rule, and then you know this one where let's say we have 2x, and then derivative of 2x is gonna be what? It's gonna be 2. Ne?
Yes.
This is the power rule. Derivative of 2x is 2, and then number 2 we have a sum rule. You know this one. The sum rule, let's say we have x squared plus 3x. When we derivate this, it's going to be 2x plus 3, right? Derivative of x squared is 2x. Derivative of 3x is 3. And then we have what we call a difference rule where we're going to subtracting. So let's say here we have 2x minus 5x squared. So the answer here is going to be 2 minus 10x. So this one is difference. It's when we are subtracting. And then also we have product rule. So product rule, let's say we have the cos x and sine x. So when we're talking about the product rule, we copy and then we derivate. We copy and then we derivate. So we're going to start by copying cos. Okay, we're going to copy cos x and then we derivate sine. The derivative of sine is what? It's cos. Okay, multiplied by cos x. So this one, the red one, we copy, and then the green one, we derivate.
Okay.
We derivate. Okay, and then plus, we started by copying cos. So now we're gonna copy sine. Plus sine, let me write with red so that shows the copied one. So the one that we're gonna copy is gonna be red, and then the one that we derivate is gonna be green. Okay, so we're gonna copy sine x, and then derivative of cos, it's what? It's negative or sine, multiplied by a negative sine. So this is how we derivate when we have product rule. Product rule, we copy, we derivate, we copy, we derivate. So we start by copying cos, and then we derivated sine. We copied sine, and then we derivated what? Cos.
Cos.
Yes. So product rule, we copy and then we copy and then we derivate, copy and derivate. Do you get it?
Yes.
Okay. And then we also have a quotient rule. Let me number 5, we have what do you call a quotient. This one, you're gonna use it a lot. Product and quotient rule, we're gonna use it a lot. You have to master those ones. Ne? So here under quotient, we have the formula. So the formula for quotient is f prime. The f prime shows that we're going to derivate, multiply by g. minus f multiplied by g prime. It shows that we're gonna derivate the prime. It shows that we're gonna derivate over g squared. For example, let's say we have cos x over x, and then they say derivate cos x over x. So if we have this function, we're gonna use the quotient rule. Okay, so the numerator one is gonna be our f. This is gonna be our f, and then this is gonna be our g. Okay, so to derivate this, we're gonna follow this equation, this formula, the f prime g minus f multiplied by g prime. Okay, and then g squared. So the derivative of y cos x over x is gonna be dy over dx. Okay, so which is f prime. Our f prime is our f is what? It's cos. So the derivative of cos is what? Derivative of cos is what? It's negative sign.
Negative sign.
So we're gonna have a negative sign x. Okay, and then we're gonna copy g. Our g is what? It's x.
X.
Yeah, multiply by x minus our f. Our f is what? It's cos x. And then our g prime. It shows that we're gonna derivate x. Okay, derivative of x is what? It's 1. Okay, you following?
Yes.
Okay, over g squared. Our g is what? Is x, so which means it's gonna be over x squared. So this is how we use quotient rule. Okay, these are the derivative rules. So we have the power, sum, difference, product, quotient. So when it comes to quotient, we use this formula. Okay, it's f prime g minus f g prime over g squared. Do you have any question here?
No, I got it.
Okay, and then the last one, it's called chain rule. So let's do chain rule. The last one, it's chain rule. Number 6. But you still remember these names, right? The chain rule, product rule, quotient.
Yeah, I still remember them.
Yeah, so on chain rule we also have the formula. So formula is f into g of x. Okay, so this is the formula for chain rule. So it's gonna be f prime into gx, okay, multiply by g prime of x. So this is the formula for what? For chain rule. So now they say, for example, they say derivate y equals to sine x squared. They say derivate this. So how are we going to derivate? It's going to be dy over dx equals to, so here, remember, here it say f prime into gx multiplied by g prime of x. Okay, so our f here, it's sine. Okay, our f here, it's sine, and then our g is x squared. Okay, so f prime, so derivative of sine is what? It's cos. Okay, yeah, and then g is what? Is x squared, so it's gonna be into x squared. Okay, multiplied by g prime, so we're gonna derivate x squared. Derivative of x squared is what? Is 2x. So this is how we derivate it. Okay, it's f, it's sine, and then we derivated sine, which is cos, and then open brackets g of x. Our g is what? Is x squared. This is x squared multiplied by g prime of x. G prime of x is the derivative of g, which is x squared, so it's gonna be 2x. You following?
Yes.
Great. Do you know that method of let u equals to x squared, and then we solve using u? Do you still remember? Let u is equals to this. Do you still remember that method?
Yeah, I do recall what you say.
Okay, let's make an example again with the y is equals to sine x squared with the let u method. Okay, let's say we have y is equals to sine x squared, and then to use that method we're gonna let our u equals to what? To x squared. Okay, and then wherever there's x squared we're gonna put u, so which means yes, which means our y now is gonna be sine u, right?
Yes.
Yeah, so now we have two equations. We have this one and this one, and then we're gonna derivate them. So let's derivate u with respect to x. So it's gonna be du over dx. Okay, so derivative of this is gonna be 2x, right? And then now let's derivate y. Y is gonna be dy with respect to u over du, dy over du. So derivative of sine u is what? It's gonna be what? Cos u.
Minus cos u.
Derivative of sine.
No, it's positive.
Cos. Yes. Cos u. Okay. And then remember we are looking for what? For dy over dx.
Yes, yes.
Yeah, so to get dy over dx, the formula is gonna be dy over dx is equals to du, or dy over du multiplied by du over dx, because you see du and du is gonna cancel each other, and then you'll be left with what? Dy over dx, right? Du and
Yes.
du is gonna cancel each other, and then we're gonna be left with what? Dy over dx. But we have the value of dy over du, which is what? Which is cos u, right? So it's gonna be cos u multiplied by du over dx, which is what? Which is 2 multiplied by 2x. And then we said we're gonna let u equals to what? To x squared, and then which means we're gonna substitute back our value of x squared. So therefore we're gonna have cos x squared multiplied by 2x. This is multiplication. Okay, this is times 2x. Yes, so you see we got the same answer as previous, as this one, cos
Yes, I see.
x squared times 2x, and then it's the same as this one, but this method it's long compared to that one, right? That
Yeah, this one is straightforward.
Yeah. Okay, so these are the derivative rules. We have the power rule, sum rule, difference rule, product rule. We have quotient rule. We have chain rule. Okay, and then
Do they give us the derivatives on the formula sheet?
yes, yes, on the formula sheet they will give you the derivatives. They will.
I won't fail.
You won't. You will never. Okay. Yeah. We have 1 hour. We've spent it like 1 hour now. So
Yeah, let's push fast so that we rest.
yeah. Okay, we're gonna do the last topic for the day, and then maybe Wednesday or Thursday we're gonna continue with Rochi. Okay.
Okay, no problem. You'll let me know when I will continue.
Yeah, so now let's do it's 1.3 maximum error for a function of 2 variables. Let me see, it's 1. What? Yeah,
it's 1.3.
1.3.
Are you done doing your advance?
Yes, I am done. I did my advanced 2023 and I got cum laude.
So you can get one for me as well.
You will get one. You're with me. Okay. Yeah.
So it's only these. Which ones are difficult for first semester?
No, I hate theory. So I hated material
Same.
science.
I hate theory.
Yeah, I really hate theory. So I really enjoyed mathematics, but Maths 4, it's long. The calculation here, they are long, you know. They are simple,
Yeah,
but
because
long.
one question is like 8 minutes.
You see?
I mean 8 marks.
Yeah. It's long.
No, I see.
So now let's do this evaluating maximum error with for function of 2.
Okay.
I thought you have already started, you know.
Hey, I've just finished my standby this weekend.
Oh.
I was on standby, and I'm tired.
I
think this is the 4th week going to work non-stop.
Is it? You're working shifts?
No, we were short-staffed, and I had to cover. We had a lot of issues the past 3 weeks, and I'm working under performance and testing department, Apple station above.
Oh, okay.
So it's hectic.
Let's say 2 or more variables. 2 or more.
Okay.
Okay, so under here we're gonna have variables x and y as our variable. X and y is we're gonna call them our variables, okay? And then change in x and change in y it's gonna be our errors. We're gonna call them errors, okay? And then when we say more, we can have variable z. We can have z also. That's why I said 2 or more. We can also use z here. So x and y is when we have 2, and then sometimes we can have z here, so it's more. Okay, and also we can have change in z, which is error. Okay. Okay, and then for function, let's say for example, we have a function with with xyz. Let's say for function f with x, y, z, and then they want us to derivate. Let's say it's u equals to, let me rewrite again. Let's say we have u equals to f into x, y, and then z, like this. And then they want us to derivate a function with these variables with x, y, z. So how are we going to derivate? We're going to say change in u to show that we're derivative. So we're derivating u with respect to x, y, z. So it's going to be change in u over change in x multiplied by change in x. No, I'm lying. It's gonna be du to show that we're derivating du over dx multiplied by change in x. Okay, plus du over dy multiplied by change in y. Okay, plus yeah, it's that sign. It's not 2. It's more like what? On the textbook, it's written like this.
Let me see. I see that sign.
Yes.
Fine. Let's continue.
You thought it's 2. Sorry.
But I hear you saying about you.
Yeah.
About 2.
Sorry. It's that sign. I don't know what's the name of that sign.
No,
I think partial derivative. Partial derivative of u over partial derivative of x plus change in x plus partial derivative of u over partial derivative of y times change in y, and then partial derivative of u over partial derivative of z multiply by changing z. So if we have a function with x, y, z, this is how we're gonna derivate, okay? So it's gonna be this u on top over the value of x times error x. And then we come to y, it's gonna be u on top over y, and then changing y. And then u over z, changing z. Okay, if we have x, y, z. And sometimes we can have a, b, c, d, e, and then which means it's gonna be, let's say here it's u, so it's gonna be u over a, changing a, u over b, changing b, u over c, so yes.
I see.
So for example, let's say we have u equals to x squared, y cube, and then z square, like this. And then they say changing x is equals to 0.2, and then changing y equals to 0.1, and then changing z is equals to 0.3. And then the same value of x is equals to 12, and then y equals to 14, and then z is equals to 12. And then they want us to, let me see, where's that question? They want us to determine the maximum error of this. Maximum error. They want us to determine maximum error. So to determine the maximum error, we're going to use this equation. To determine the maximum error. This equation is going to help us to determine what? Maximum error. Okay?
Yeah.
Okay. Let's move forward and then determine the maximum error. So it's gonna be the absolute bars on the side here, and then multiply by u. All the time it's gonna be absolute bar changing u, and then we're gonna have this absolute bars, multiply by, and then we have absolute bar, and then absolute bar. I'm gonna write it clear on the other side. All of this is gonna be multiplied by what? By u. Okay, so let's move forward. Let me write down. So our u, it's x squared, y cube, and then z squared. So which means our change in u is gonna be partial derivative of u over partial derivative of x, because we start with the x, multiply by change in x. Okay,
Yes.
plus then we come to y, partial derivative of u over partial derivative of y, multiply by change in y. Okay, plus we come to z. Z is gonna be partial derivative of u over z, change in z. Okay, all this we're gonna multiply it by what? By u. Okay,
By u.
yes. And then what we're going to do now, we're gonna get change in u. Change in u equals to the derivative of u with respect to x. So we're gonna focus here. Remember, we have x squared times y cube times z square. Okay,
Z square.
yeah, so this is product rule. We are multiplying. Ne? This is product rule. So on product rule, remember we said we copy, we derivate, we copy, we derivate. Ne? And then now we're gonna start by focusing on x. Okay, so we're gonna start by derivative x. So derivative of x is what? It's 2x. Ne? And then we copy. We're gonna copy the remaining y cube z square. Okay, all multiply by what? By changing x. Okay, you following?
Yes.
Okay, and then now let's come to y, plus we're gonna come here to our formula. Now we're focusing on y. We're gonna derivate y. Y cube, derivative of y cube is gonna be what? 3y squared. And then, yes, and then we copy the remaining. So we're gonna have x squared and z squared multiplied by changing y. Okay, and then now we're gonna go to what? To z plus the z. We're gonna derivate z. Derivative of z squared is what? It's gonna be 2z, and then we copy the remaining. Okay, so it's gonna be x squared y cube multiplied by changing z. Okay, and then now we have all of them multiplied by what? By u. Okay, like this. So we're gonna substitute the values. We have 2x y cube z squared multiplied by changing x plus 3y squared x squared z squared times this, blah 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 blah. Okay, we have this. So from here, from our equation, we are given what? Changing x, changing y, changing z, the value of x, the value of y, and the value of z. What we have to do is just to substitute here. X is 12. Y, it's what? It's 14. Z, it's 12. So. Changing x is what? It's 0.2. You just substitute. After substituting, you're going to get your answer. Okay?
Oh, so the only trick here is derivating the equation that you are given.
Yes.
After you substitute with the given values.
Yes.
Okay.
Yes. So after substituting, you're gonna get your answer. So let's say you're gonna have the change in u, your answer. So when I calculated, I got answer as 5,960,908.8. So remember, we're multiplying everything by u, right? We multiplied everything by u, and then now we can divide both sides by u, and then we get the answer. So it's going to be changing u over u over u, and then we have this 5,960,908 times 8. Okay, and then now we can calculate the value of u. Okay, the value of u is gonna be x to the power of, is it x to the power of 2, y to the power of 3, and then z to the power of 2. And then we're gonna substitute. So our x, it was 12, and then our y, it was 14, and then our z was 12, and then we're gonna get the value of u, okay, which is 56,899,584. Okay, and then now you're gonna divide these two, then you get your answer, you get your maximum error. Okay, so changing u over u, so it's gonna be 56,0908 multiplied 8 divided by 568,99584, and then you're gonna get 0.1047. So the maximum percentage error, when they say maximum percentage error, you just multiply this by 100. Okay, so it's gonna be 0.1047 multiplied by 100, and then you get your answer as 10.47. Okay, percent. So yes, this is the maximum percentage error. When they say maximum percentage error, you calculate, you just have to derivate, just know how to derivate, and then you substitute. That's it. Yeah.
Okay.
Yeah. It's 8:30 already. Let's say this is the last one, and then I don't know when, maybe tomorrow or the following day.
Nah, I will do the examples.
Okay, I want you to do this one then. Let's say this is an example for sure. Yeah, for this example, let's say we have k equals to A squared times BC over D. And then they say A equals to 15.3. And then B equals to 5.112. Ne? And then C equals to 3.956. And then D equals to 11.945. Okay, 7. And then they want you to determine the maximum error. To determine the error. So this one, where is it? Where is it, Vel? Where did I calculate the percentage? Oh, it's here. It's here. This one we call it error. Okay, this one we call it error. And then this one we call it maximum percentage error. Okay. Yeah.
Oh.
This is error, and then this is maximum percentage error. When they say maximum percentage error, just know at the end you have to multiply your answer by 100. And then if they say calculate the error, which means it's going to be 0.1047. Ne?
Okay.
Yes. So here, where's that question that I was writing? Okay, it's here. And then here, I think it's the example. You can just follow the example and do it.
Okay.
Yeah, example 1.5. Yeah, please do example 1.5, and then if you're stuck, you're gonna ask me. You can send me a message on WhatsApp, then I will reply. Ne?
Okay, no problem.
Yeah.
Do I have your number?
Yeah, you do.
I have a lot of unsaved numbers here.
The one that I shared the link.
Oh, yeah.
Okay, so example 1.5, you're gonna do example 1.5, and then if you're stuck, you're gonna ask me a question. It's the same as this one, but here we were using the XYZ, and then here they were multiplying. Ne? That's why we use product rule. And then here on that, this A square BC over D, it's more like what? Quotient.
Quotient.